Good afternoon, everyone. Welcome to this second installment of the July mini school on what does it take to publish in mathematics. Yeah. And as you know, we have a team of presenters. Last week, we heard Professor Amartya Goswami from the University of Johannesburg. And today we have Professor Zurab Janelidze from Stellenbosch University. Yeah. Professor Janelidze is the coordinator of one of the NITheCS research focus areas, yeah, on mathematical structures for foundations and innovation, yeah. He's also the president of the Mathematical Society, of the South African Mathematical Society, and he's also the chair of the board of director of the South African Mathematics Foundation. So essentially, he's Mr. Mathematics. Yeah. Zurab, we are very glad that you, together with Amartya, offered this mini school. And if you are ready to share your screen, you're most and welcome to start the second installment of the presentation. And the participants know the rule of the game. You're welcome to ask questions in the Q&A or raise your hand at the end and ask your question then. Yeah. So Zurab, thank you very much.
Thank you very much, Francesco. Thank you so much for your kind introduction. It's an absolute pleasure as well as honor to be back presenting an NITheCS Mini School, especially doing this together with my colleague Amartya, who currently is in Austria, right, Amartya?
Yes, yes, I'm in Austria.
And thank you so much, Amartya, for being able to allocate this time while you're on your visit in Austria. I will start saying a few things, and then maybe you can come in, Amartya, because originally we planned that I would give a presentation on my own. So we haven't rehearsed how we're going to interact, but we can maybe figure it out as we proceed.
Absolutely.
Maybe it will be useful for me just to get an idea to ask participants to perhaps write in the chat which research area they work in, if they already work in a certain research area. If they're just students, they can write what are the most interesting research areas for them. It will be nice to have this overview that could inform me in the kind of things I will be using as examples for whatever I want to say. So everybody's welcome to write in the chat their research areas. Thank you very much for that, everyone.
So far we have enumerative combinatorics, simulation and modeling, PD with deep learning.
Yeah, so let that be on, and then at some point we might come back to that. I will be constantly looking at it. It's on my window here. I want to begin with more or less where you left off. Amartya, you gave a very nice insight into what it takes to publish mathematics. And maybe I want to almost like zoom out from where you left off and give a sort of strategy for determining whether your work is ready or not for publication. And then we can also talk about what kind of journals is your work most likely to be published in, and also we will talk about the different ways of distinguishing journals from each other. Some of them are very difficult to publish in because there is a lot of competition. They are regarded as prestigious journals, whereas other might be easier to publish in, and also to make an informed decision as to where your work lies and what would be the best options to try. So I want to offer some kind of rubric in helping one to determine where is the work positioned, whether it is ready or not for publication. And the rubric I want to offer contains 4 aspects. They are going to be ordered not in relation to which one is more important. All 4 of them are almost equally important. So The first one I want to write out here is applicability. And this is not necessarily about applicability to real life. I will talk more about applicability in a moment. And the second one is novelty. The third one is complexity. And the fourth one is completeness. So your paper, or maybe paper in progress, is somewhere in the middle here. This is the work you've done so far, or maybe are planning to do. And what we will talk about is how to measure the 4 aspects of your work, which are very important in order for your work to be published. And also, they determine the types of journals that your work will be published in. So let's begin with applicability. Let's break this down. What does it mean that your work is applicable? What do I mean by that, at least? Maybe I'm going to make more space for me here to write that down. So you can do mathematics in such a way that you have never ever seen any kind of mathematics before, and you basically reinvent the wheel, or maybe several wheels. That's possible. That's how people originally discovered mathematics. That's how we're discovering mathematics. In the very, very old days, there wasn't necessarily a lot of literature to look at, right? Maybe something could be learned through storytelling, but some of the things often were genuinely new. So you can do it that way. But the likelihood of simply rediscovering known things and not really contributing anything new is very high. But also the likelihood of people simply not being interested in what you do, just because the thing you're doing is completely unrelated to everything else we know in mathematics. So this is one aspect of applicability. How does your work relate to, or how is it relevant to, or rather, not how is it relevant, but rather how it makes use of existing knowledge. Use of existing knowledge. But then another aspect of applicability is, because I mean, the idea is that if your work makes use of some existing piece of knowledge, then there is implicit applicability. So whoever works in that area of knowledge might potentially need your work at some point, just because it is closely linked to that. So that's why we categorize this as applicability. But that can also be measured, how much it is obvious that your work is actually relevant to that existing knowledge. So I'm going to make it as a separate bullet point: relevance to existing knowledge. So you see that this connection with applicability is kind of, already we see 2 directions there. So use of existing knowledge is almost like an arrow going this way, whereas relevance to existing knowledge, one can think of relation in terms of an error going the other way. So each of these are in a way bidirectional. Now, at this stage, your work could be relevant to existing knowledge, but it doesn't necessarily mean that it is useful in the sense that somebody can now take your theorem and immediately after that be able to solve some problems that they've been struggling with. First of all, if there are like obvious problems to be solved with your work, you most likely want to include it in your own paper already, which will then leave a little chance for others to use it in ways that you didn't anticipate. So that's where relevance is a kind of potential usefulness. But there are cases indeed where your work it can already clearly be seen to be useful, but maybe to use it, one would require a lot of further work, so you wouldn't want to necessarily include that in your paper. So we could add this as another aspect, usefulness of your work. And this doesn't only refer to usefulness in real life. Usually when we publish in mathematics, it's useful to mathematics. We don't, I mean, even in the field of applied mathematics, we do not publish things that are really about describing how to use mathematics in the real world. That if you're publishing something like that, it would most likely be published in a journal that specializes in that area of application. But even though you might not be describing explicit process of application of your work, you might still produce something that is clearly applicable to real life. And so that is included under usefulness of your work, but it might not be applicable to real life at all. It might be applicable to other areas of mathematics, applied or pure, where your methods or your theorems could be useful to do something there. So let me put in brackets here, within or beyond mathematics. At this stage, maybe I can ask you, Amartya, would you like to propose some other aspects that can go under applicability?
No, more or less, I think you covered the main points. Sometimes, if there is a problem which people are trying to solve and they are lacking some kind of tools or some kind of notion, and if one can introduce that, then that can be considered as a big applicability with respect to the existing work.
Right. So yeah, so that kind of, I think what you said is on the border of what I've already written and something I haven't written, which is opening up new directions of research. So you might do something that is useful not from the point of view that it solves an existing problem, but it's useful that it brings in a lot of questions one can ask that suddenly after the concepts perhaps or theorems that you completed in your work inspire this new direction of research. So that's also applicability because this new direction of research is not entirely new. It will be something that kind of is positioned in existing knowledge, not from perspective of clarifying something that was already being thought of, but rather in terms of opening up. Maybe it could be opening up new bridge between two fields. Sometimes
yes,
that is also how it happens. So that's another way of thinking of applicability, whether your work opens up new directions of research. And it's not to say that in order for your work to be publishable, all of these types of applicability need to be present there. It's just that you can like think of it that as a kind of giving a score. Each of them contribute a certain score, and that's how you can determine the overall score of applicability of your work. And in some cases, you might have one of them contributing to a lot and then the others less. And So the overall score is still fine. Anything else we should add, do you think, under applicability?
No, I think for the timing is good enough.
Okay, fantastic. So we've broken down a little bit this aspect.
Hello.
Looks like.
I think we lost Zurab. Sorry. I wasn't sure whether it was my problem or Zurab problem. Let's give it a minute. Maybe Amartya, you can improvise.
Yes.
I think he's back. Yeah.
Okay, Zurab is back. No
Yes.
worries. No, Zurab is gone.
Now, maybe he's.
Okay.
Yeah, he's rejoining. Yes.
Zurab is back. Okay, welcome back, Zurab.
So something interesting happened. You said the word improvise and then it turned off. I don't know what happened.
I don't know.
Were you kicked out before that, or were you saying improvise in the context of what we were saying?
No, you were frozen, Zurab.
Oh, I see.
And I told Amartya that until you unfreeze, he should improvise.
I see. Okay, sorry about that.
Yeah, no worries. It happens to the best of us.
Well, I am giving this lecture from my office, so I think this is the best I can do it, unfortunately. Hopefully, I will not freeze again.
No, please, go ahead.
I said novelty, and then we were going to break this down. And so I was saying that you can pick randomly two very large numbers and multiply them and write down the answer. And you might then check on Google that nobody has published this answer to that multiplication before. And you might think that you're doing something new. So in fact, there is nothing new about that. It's exactly the example of something that is not new, because in mathematics, we don't care about answers. We care about the methods that allow us to get answers. And I see now that there are already some very interesting questions, which I'm going to address as I go along. Let me just first finish my line of thought. So there needs to be something new about the mathematics itself. It shouldn't be just taking an existing method and working out the answer that's based on that method. Now, you might ask, isn't all of mathematics just methodological? And in fact, no. In fact, it was proved early in 20th century that there isn't a method for proving theorems. So when we discover how to prove a theorem, each time there is some creativity involved in it, which we will not be able to write down as an algorithm. Do this, and then you'll be able to prove a theorem. Of course, with AI, it's possible that at some point, it didn't happen yet, although it happened already in many areas, but not in serious mathematical research. It's possible that we will arrive to a point where AI will be able to solve all mathematical problems that we can solve and better. That's fine. But as soon as that happens, after that, when you solve a problem, a mathematical problem, it wouldn't be considered new, just the solution of the problem, because we know that, I mean, it wouldn't be much novelty, because we know that we can use AI to get the same thing. So there's nothing new about the process. However, maybe identifying concepts that could be useful is something that a human being can do. And again, maybe AI will beat us in that as well. So it is possible that a few years down the line, all of these aspects that we're discussing today can be done in such a way that AI is better than we are in this. And at that stage, I think our lectures, Amartya, will become no longer up to date.
Yes.
We will have to give a different lecture on what it means to publish in that kind of era. But for now, mathematical creativity is a very, very mysterious process. We're not able to automate it for now. And it has achievements that span not just several, but maybe 100 or more years. For a good example of this is Fermat's last theorem, which was the final puzzle piece was found after intensive work by Andrew Wiles. But before that, there was a lot of progress that led to that point in time. And that research spans more than 100 years. And so it is actually a collaborative effort to arrive to the solution to this problem. And a lot of new mathematics had to be developed in order for Andrew Wiles to be where he was when he made that final significant contribution. So it's very subtle what is mathematical novelty. In a sense, it takes you to become a professional mathematician who publishes in high-quality journals to have a good sense of what it means that your mathematics is new. But in a very primitive language, novelty is about novelty of the methodology, and not just using existing methods to solve a problem. So let me put methodology here. Part of novelty is certainly when something is unexpected. You might be using existing methodology, but somehow nobody ever thought of using that methodology, and then it gives you an answer that people who were working in that area were not expecting the answer. And so it's new from that point of view, even if maybe existing methodology is used. So that's another aspect of novelty. Would you like to?
Yeah, and this point is, this point is very important, this unexpectedness, because the more the results are surprising, the chances of the paper or the work get accepted in a better journal. And if it is a routine exercise, in some sense that the solution is almost obvious if only somebody need to do the work, and that has not been done. So more it's surprising, it's better with respect to the quality of the journal as well, because not only having methodology, but that methodology need to bring something completely unexpected. So it's very, very important.
New ideas. There might be an idea that's completely new that people haven't thought of, and which is not necessarily fully fleshed out yet. So the paper might be proposing simply a new idea without really solving anything. Maybe there will be substantial content in the paper to explore this idea at the basic level. But overall, I mean, this would be the kind of thing that often would be maybe linked to this part, opening up new directions of research. And now that I think about this more, I think I missed one other point under applicability, which was connecting existing pieces of knowledge, building bridges between pieces of knowledge. Connecting existing knowledge. Let me say knowledges. So some sort of new idea might also link to such a connection.
And probably this new idea should have some kind of applicability. Otherwise, why this new idea is novel, in some sense also determined by its useness usefulness with the existing problem. So, I mean, novelty and applicability are not completely disjoint or detached concepts or idea, right?
Yeah, well, that's what we're trying to do here. So we're trying to identify these aspects, and the whole point of this rubric is that indeed you can have your work to have a very high score on this side, but a very poor score on this side, and then your overall score ends up not being so high. So the idea is to have some kind of reasonable scores in each of these, and then your work is it can be published.
Yes.
All right, let me stop here for novelty. For now, I think this is the most difficult one to dissect, because it really has to do with something very very human creativity. What is human creativity is something that nobody knows yet, and it's probably that's why it's more difficult to dissect this one. Also, you will find that in judging your paper, when the editor of the journal judges your paper, very often you might find that they were unfair to your work. And in cases like this, often it is because from their sense of what is novel, maybe your work isn't so novel. But maybe from your sense it's novel because either because you're new to research, or because you have some expertise that the editor or the referee doesn't. And so you actually are more qualified to judge novelty, and that happens too. And in that case, one shouldn't be upset with the journal. That's a normal human thing. You can try another journal which will be more sensitive or more aware of your field, so they can then also make similar judgment as you did. Complexity. It is very difficult to clean your house, especially if you've got a big house. If you want to clean all the floors and wash all the dishes and everything, I experienced this when my wife was away for a few weeks. It's very difficult. It's a very complex thing you need to do. But unfortunately, describing what you did will not get you a published paper in mathematics. So there are lots of things that are complex, but are not complex from the mathematical point of view. But at the same time, if you do some mathematics that has no complexity in it at all, if it's very simplistic what you do, no matter how great new ideas you have, also that will not be sufficient. So the effort it takes to do the actual work counts in determining whether your work is publishable or not. But then there is also depth, mathematical depth. It might take you a lot of effort to do something, but that's just because it's routine work. It just requires lots of procedures to be applied, but everything is kind of determined by the method that you're using. You have to put effort in it, but there is no mathematical depth. You don't really have to think what you're doing. You just do the obvious thing. So while effort will be high, the mathematical depth will be not so high. Let me say, let me separate these two by calling it work effort and then thinking effort. You do want to spend a lot of time thinking about your work, and this thinking should be making a significant contribution to your work. If you're not doing that, if you're just putting in the work effort and not the thinking effort, you don't need to put thinking effort, then it's very likely that you'll produce a paper that is not publishable, at least not in a good quality journal. And this somehow does link up, the thinking effort here does link up with novelty, although there's a fine line there, because methodology could be already known. It's just that the way this methodology unfolds in that particular environment, could require some thinking. So it's a bit becomes a bit difficult to distinguish between novelty and complexity. They're kind of opposite ends of a spectrum in some sense. But you want to have both of them if you want to have a good quality paper. Anything else do you think we should put here under complexity?
Maybe, I mean, depending on the research area, possibly, complexity can happen in at least in two different levels. One is the original idea, which part of the novelty you'd already described, could be itself is complex, and then your results become much easier. They're not that complex. Or maybe the original ideas are not that complex, but to use those ideas, actual work or the proving the theorems is complex. So depending on the problem or depending on the research area, both of them, I mean, one of them or maybe both of them is applicable. So not necessarily that only my proofs should be extremely complicated, because sometimes the foundation is very complicated, but once the foundation is done, then things comes much naturally or less complex way. So maybe that is also relevant to justify or to explain this complexity.
Yeah, maybe in relation to that, I will put here mathematical. Let me put here intricacy, how intricate the thing is.
Yes.
It's the actual, it's not the complexity of your work rather, but the actual complexity of the mathematics you've created, how delicate it is, how complex it is. Just to give a simple example there, if you're given a piece of wood and you want to make some kind of woodwork out of it, you can make a very, very intricate, very complex wooden structure, something that would be completely useless, but it will be very, very complicated, right? You can do something very funny. And then, so this will be an example of something that's very complex. You might have had to solve a lot of problems to do this and use a lot of new ideas and all of that, the way to attach these things. So this could be very complex, but something like a chair would earn you much more money if you just sold a chair, because chair is so useful. So it's an example of how you can overdo complexity and then still not be able to publish because the other aspects are missing.
Yeah, very much.
And then the last one in our rubric is completeness. And this is, I think, a lot of times, as an editor myself, a lot of times I find that the authors that submit papers that I handle as an editor, I'm an editor in, I think, 3 journals, they undermine this. Completeness is very important. And so let me emphasize a few points here. One thing is the actual mathematical completeness of the theory. Mathematical let me say this, obvious mathematical questions have been answered. Obvious questions addressed. If you're, especially when you're proposing like brand new ideas in your paper, there are some obvious questions to be asked. And if you dismiss them, and the one who reads your paper comes up with these questions, sometimes answering those questions might give a completely new perspective and a better perspective actually on your work. When an editor or referee notices that these obvious questions would have really improved the quality of the overall work, and they're really very obvious, they will tell you that you need to, if everything else is fine, they will just tell you that you need to revise your paper and answer these questions. So you do want to make sure that mathematically, as a mathematical story, the story is complete. Now, completeness of mathematical story is not about asking obvious questions, it's also about working out examples.
Yes, very, very important.
Now, one might argue that examples are also what play a role when we talk about relevance to existing knowledge, because indeed examples link your work to existing knowledge, but sometimes they don't. Sometimes these examples can be also very strange examples that are not really useful from the point of view of application, but they're still useful from the point of your theory, that they clarify connections between things that you're doing by either providing an example or a counterexample, kind of concrete aspect of your work. So examples help us to have a concrete picture of what's going on. So the question you might want to ask, is my work complete from the point of view of its concrete picture? But then abstraction is also important. You might be doing something that is very special to a very specific mathematical environment, but all your methods that you use are obviously abstractable to slightly more general and even more relevant environment. And so if there is a very, very obvious way in which your work abstracts, and you haven't considered that abstraction in your work, then the editor or the referee might tell you, oh, well, wait a second, you're proving something for odd numbers, but actually what you're proving is true for all numbers, not just the odd numbers. So why are you doing it for odd numbers? So that is also important, and that also contributes to completeness of your work. I also want to add here the quality of your text. If your text isn't of good quality, if the way you compose your sentences and paragraphs and sections if it's not done well, it also gives a lack of completeness, because when you do it well, it might actually give you a better organization of your mathematics, and hence also it might allow you to come up with questions you wouldn't have asked before until you saw the completed work in terms of its presentation. So good presentation also counts as part of completeness, I would say. If your presentation isn't good, then you shouldn't consider that your work is complete. Anything else you'd like to add, Amartya?
No, just two remarks. One about these examples. It is better to have some natural examples rather than artificial or pathological examples or trivial examples, because if we wanted to justify a new idea or to establish a new idea, we need to justify it from non-trivial examples, and also non-pathological, not artificially creating. And about this good presentation, it is very, very important. It's not that I just did some result proofs and put them in some haphazard way, because if there are no coherence, there are many papers just got rejected because it was poorly presented, even if your mathematics is excellent, because it does not tell the whole story, what you are trying to do here, and they don't care about whether your results are very important. Definitely.
Yeah, so what you said, I added it under simplicity. So you do want your work to be as simple as possible, so that it's as easy as possible to read for someone else. And here you might think, okay, we've got a contradiction here. Now, on one hand, we want the thing to be complex. On the other hand, we want it to be simple. So how does that work? Well, the thing is that when we talk about complexity, it has to be naturally complex, not artificially complex.
Yes.
Not that you make something look complex just because you want to have it complex. And actually, some people do that. Some mathematicians, even good ones, sometimes could maybe deliberately present their work in such a complex way that unless the reader, the referee is a real expert, they will not notice that it's simplifiable. And then they might consider, oh, this is such a good quality work because it's so complex, but actually somebody else might read it and see, oh, wait a second, it's actually very, very basic work, because, I mean, it was presented in a complex way, but it can be simplified. So, like, for example, if you're giving a counterexample to something, right, and you might give a very, very complicated counterexample, but then it might turn out that actually just the first obvious example one would think of is already a counterexample. So now all that effort of working out the complicated counterexample will actually count against you, because it means you didn't make sure that your work is complete from the point of view of its simplicity. So you do want to try your best for your work to be as simple as possible, and yet there should be complexity in it. Then you can say that you've got high score both here and here. By the way, I'll just give you one example from my own story. So there is a certain paper of mine together with my former PhD student that's published in Advances in Mathematics. This is considered to be a very good journal, especially in pure mathematics. And it took us like 7 years to write that paper, because the proof of the main result is 25 pages long. And so we already had ideas for how to prove this result in the first couple of years. Why did it take 7 years? Because we wanted the proof to be as simple as possible. And so we worked for 7 years to really simplify the proof, and the best we could do is to simplify it so that it becomes 25 pages. And we couldn't simplify it more, and at some point we felt, okay, I don't think anyone else can do it better than this. So then we decided to submit it for publication. Another thing that definitely should be added here, apart from simplicity, is correctness. That's also part of completeness. You shouldn't have mathematical mistakes in your work. And you might think, oh, if I make a mistake, I'm such a bad mathematician. No, everybody makes a mistake. The whole point is that you make mistakes and then you fix them. But if you didn't review your own work and try to look for those mistakes and then try to fix them, then your work isn't complete yet. So correctness is also extremely important. I think it happened actually with Fermat's last year. On the first publication that Andrew Wiles submitted had a mistake in it. And then referees picked it up. And even though his work was magnificent, right? The paper was rejected. I think it was rejected. Maybe I'm not telling the story right. But anyway, so either it was rejected or retracted, I'm sure. And then he managed to solve the mistake together with a student of his.
Taylor.
So, I see, yeah.
Taylor.
Yeah. Anyway, so I think this is maybe enough breakdown of completeness. And one way to ensure completeness of your work is to reread what you've written. Maybe even after like a little bit of a break, you rest your mind, you do some other things, you go back and you restudy your work, because when you do that, it's almost like somebody else looking at it. You will have those obvious questions popping up, which you might not have had at that point in time. You will be noticing mistakes more than when you were focusing on it, when you were writing it. You might immediately notice that some things can be simplified the way you've written. So writing a paper is not like something you do like in 1 week and then it's done, and then you just submit it, even though Amartya and I have a few papers like that. But that was because the paper was rather short, so it was easy to reread a few times during that week because of the length of the work. Okay, so let me now go to the questions. I want to maybe address some of these questions right now before we move on. There were not many of them. So one of them was about, and others can also write questions as I'm talking. Can a research be relevant on its own, not necessarily applicable at present? So we took here a broad notion of applicability. So it can be that your work is relevant to existing knowledge, but that relevance means that it simply makes use of concepts from existing work. Maybe the question you're answering in your work relates closely to other questions that have been answered or not answered. So it's relevant, but not necessarily useful yet. So it's not applicable in the sense of it's not necessarily useful, but it could still be relevant without being useful. So the answer is yes. I just use this very broad term applicability for both relevance and usefulness. And then the other question was, yeah, sorry.
Actually, usefulness is already embedded, even if it is relevant on its own, because it is useful with respect to understand the problem, or with respect to understand the idea, or with respect to understand the structure. So there is some inherent usefulness, not explicitly maybe.
Yeah. So I use the two terms here to distinguish real, not inherent, but actual demonstrable usefulness. And then the other question was, is it possible that applicability is not so clearly known? However, I studied something, came up with a slightly different synthesis of the existing works, wrote a document, now I should submit it somewhere. So if your work is just repackaging existing knowledge, then it will lack in, first of all, it will lack in novelty. If it's just repackaging, probably there will be no new methodology there. Probably there will be no new ideas as well, if it's just about a different synthesis of existing works. Unexpectedness also is not clear. We actually have a paper like that with Amartya and I recently published, which didn't really have much of any of these three, but it had a very strong component of this.
Yes.
So if that new way of putting, if that new synthesis you're talking about, if that really gives a new insight into, I mean, if the applicability score is high, then it's possible that the novelty score wouldn't be so high, and then it's fine. So if that slightly different synthesis of existing works is really applicable, more than in the old synthesis was, then you can still publish it. But if you're also not sure of applicability, then it will not be published unless it's a very, very bad journal. Yeah, so that's the idea. So the idea with this rubric is for you to kind of measure your work in terms of all of these four components, and you do want some kind of balance. So if somewhere the score is low, you want that elsewhere the score to be exceptionally high, to make up for that lack. And then another question was whether the length of a paper matters, and the answer is no. Obviously, if the paper is very short, then it's likely that the complexity score will be low. You cannot really write complex mathematics in a very short paper, so you will be suffering on the complexity score if the paper is very short. Yeah, you might not be suffering on completeness at all, because it might be a question that doesn't really require a lot of investigation. And so then you will be expecting at least that to be in place. If it's a short paper, it has to really make its point, and the point needs to be very clear. But then you do want to make up the scores that you lacked on complexity in terms of either applicability or novelty, or both. My first paper actually was just, I think, 2.5 pages long. So in terms of complexity, the score was quite small. But there is a lot of new ideas it gave rise to. So it contributed to a little bit to a few of these, not necessarily this one. This would be something that may be more for someone who does really applied work, but it definitely contributed to this bit and these two bits as well. All right, now let's, we have a bit of time left, or maybe we should end here and open for questions, because I already addressed some questions, but I'm not addressing any of the ones in Q&A. I will leave this for Francesco. I did want to say a few things about the quality of journal, but maybe we can see what we should do. Francesco, would you like us to end here, or can I go on?
You're most than welcome. I'm sure we'll have a few questions. There is one in the Q&A. and some anonymous attendee asked, what about the novelty of the ideas given by ChatGPT with little guidance and seems appropriate as well?
Yeah, that's a very, very interesting question. So you might use ChatGPT for some of these things, right? For example, not just, I mean, you might use ChatGPT for novelty of ideas. However, it's a bit unlikely, you know, because ChatGPT takes input from existing human knowledge. So the chances of it really producing a new idea is very small because it just copies human beings. But it is still possible. I've definitely seen some kind of indications of that. But then those new ideas would have to be developed further. And so then you would also want maybe ChatGPT to do that. So among all these things that we listed, it's highly possible that in many areas, ChatGPT can really help you. Like even for completeness, right? For example, in terms of good presentation, definitely. If you have some English problems in the paper, definitely ChatGPT can help you there. Not fully, because ChatGPT doesn't necessarily know mathematical English as well as a professional mathematician does, but it might help you a little bit. So it's a very interesting question. I think that's exactly what I was talking about earlier at the beginning, that at some point AI might overtake us in all of these aspects, and then our lectures will become outdated. One has to declare. One thing is clear. One has to declare if ChatGPT was involved. One has to declare how it was used.
Yes.
And then if the scores in other criteria which are human contributed are still high, then why not? I mean, it can also be that you actually solved a known problem completely by using a computer. That will definitely be publishable. If that would make your applicability score very high. You might use the computer to solve it, then you will have to explain how the computer solved it. But and there are many such papers actually. There is a journal called Journal of Algebra, which recently, not so recently anymore, introduced it's the top journal in the field of algebra, but recently it introduced a new section, which is for computer algebra. So that's for doing algebra using computers. And the requirements there are obviously different than in the other section. So it's impossible to give a all size fits all answer to this question. In each individual case, better to consult with the expert whether before submitting you might want to show to the expert.
Zurab, before we ask Keegan Anderson to ask his question in person, can I add a follow-up questions?
Yes, please.
You and others use tools like that lean to prove mathematical theorems and so on and so forth. Yeah. Is there any attempt out there to couple ChatGPT to lean, for instance?
That's an excellent idea. Lean allows you to make sure that your proofs are correct.
Yes.
And ChatGPT seems to be good at coming up with random ideas. So coupling them might create something very powerful. And I've seen recently some papers. I think one of them I even forwarded you a picture of. I think people are already thinking about this, but there isn't yet a system that has been published that does this in a very good way. So there is certainly some work in this direction, but the work is not yet such that we can start using it in our everyday mathematics.
Okay. We will see.
we might want to do something like this at NITheCS.
Yeah, it will come at some stage. Yeah, no, that will be very interesting. Yeah, no, because there is an interface between ChatGPT and Mathematica already.
Yeah.
So you can speak to ChatGPT and it converts this into Mathematica code.
Yeah.
So maybe there is something like that for Lean as well. And if not, maybe we should do it. Yeah.
Absolutely. So it's one of the ideas I wanted to suggest to the group in the focus area that I coordinate, that maybe we can try to take all the results we obtain in this focus area and encode it in Lean, and then start using Lean and with ChatGPT as a way to help us with the research as well. So I'm very keen on exploring this, Francesco.
Yeah. And I think, Zurab, do you know the link to Lean by heart? Someone in the chat asks, is it lean.org or something like that?
I can very quickly find the link, I'm sure.
Yeah,
let me quickly do that.
I think I just found, I think it's leanlung.org. I think.
So Lean is not the only system, but currently this one seems to be more popular than the others.
No, just an example. Yeah.
I want to share. Let me share the screen to show you how it looks like. So this is a certain page that I randomly found, and it has some pieces of mathematics that have been already implemented in Lean. Let's see what it says about functions. Now, the other thing is that you have to learn the language of Lean. That can be challenging. And again, ChatGPT or AI system like that could help us translate from ordinary language to this Lean language. Yeah, so at the moment, learning Lean is itself a technical endeavor. The Schroeder-Bernstein theorem is a theorem that I often give to students to test whether they are good at mathematical problem solving or not. And usually those who solve this problem end up doing postgraduate studies in mathematics. So it's nice to see that, well, maybe sad to see, but it's nice to see still that it's been embedded with Lean.
Okay, but maybe we have the topic for another mini school, Zurab.
Yeah. One other thing I wanted to show before we end off, it seems like there are no more questions. So just a quick thing to show is the ranking of journals in terms of quality. Amartya, can you remind me what I should?
Sysmago ranking?
Sysmago, yeah.
Yeah.
Without a C. There's a C too many. Yeah, that one. Yeah.
So unlike the impact factor, which gives you ranking mostly based on applicability, this ranking here is supposed to integrate all other aspects as well that we talked about in various complicated ways, but it seems to manage it quite well. So if you're publishing already papers in mathematical journals, you might want to look at this table and determine what is the ranking of your journal, the one that you're publishing in, to help you guide in terms of whether the journals you're publishing in is of good quality or not. So that's what I want to say. Like, for example, this is the overall mathematics list, and you see here Annals of Mathematics, which is a very famous journal, very historically old as well, appears at the top of this list. So the lecture of today should be useful for determining how to publish in a higher quality journal. That was the whole overall kind of message of today's lecture. And so to determine that, you want to make sure that your scores in terms of these different aspects that we discussed are high. Of course, I didn't give you a mathematical scoring system. It's an intuitive system. But nevertheless, if you manage to raise the scores for applicability, novelty, completeness, and complexity, then you'll be able to publish in higher quality journals than you currently are. Thank you very much.
Thank you very much, Zurab and Amartya, for another very nice lecture. And just a reminder to the participants, then the third installment will be next Wednesday, again at 2 p.m. Yeah, so please join us again next week. And after this mini school, you will be all ready to publish in the best mathematics forms. And don't forget to put the NITheCS affiliation on the paper.
That's right, yes.
That's very, very important to us. So please make a mental note. Every paper, add the NITheCS affiliation. Yeah, excellent. So thank you very much. Have a good afternoon. Thank you very much to the two speakers. Thank you very much for all the online participants. Thank you. We'll see you next time.
Thank you. Thank you.
Bye-bye. Cheers.
Bye-bye.
All the best.